Hello, we are Eczematch.
Presented by Sean Fernandez,
Kevin Kiatupago.
Stella is frozen. She's saying in the Slack that her computer froze, so you guys might just want to.
Okay, Stella Liu. Kathleen Pan.
And Neha Selva.
This is the part that Stella presents.
Sorry, my computer froze. Okay, I'll start. I'm sorry, my computer froze. This product was inspired by a skin condition many people around us have. Kathleen's friend, Neha, my friend, my sister all have it. It's red, flaky, scaly, and itchy to the point where it hurts or even bleeds. The skin condition is called atopic dermatitis, which is a type of eczema and a chronic illness that causes inflammation of the skin, meaning the skin becomes red and itchy. Currently, there is no cure, only treatments and things to avoid like certain soaps and other skin irritants. Although current treatments do provide relief, it's annoying to carry ointment around and constantly apply it. This skin condition is very prevalent in the US, and it commonly starts in children and continues to adult age. It has lifestyle impacts as well as economic and societal impacts. Patients experience helplessness and sadness and miss more work and school days due to the unbearable itch. There's also increased healthcare costs from constant doctor visits and treatment purchases. In 2013, the cost to the health system to treat atopic dermatitis was $314 million. The annual economic burden of eczema, including medical costs, lost productivity costs, and quality of life impacts, is conservatively estimated at $5.3 billion. As you can see in the graph, the percentage of children with eczema and skin allergies had an overall increase from 2000 to 2010. The global atopic dermatitis treatment market is expected to grow $8.9 billion from 2019 to 2024. Along with the rapidly increasing population, incidences of atopic dermatitis is expected to increase. More healthcare is also accelerating the growth rate of the market. The top markets for atopic dermatitis treatment are the drug treatment and topical segments, as they hold the highest market shares.
To help people like myself and Stella's sister, we are proposing a nanoscience-inspired hydrogel patch which uses polyepsilon caprolactone nanoparticles to release hydrocortisone acetate molecules over a prolonged period of time to relieve and soothe irritated skin.
Eczematch is designed to protect moisture from escaping the skin where the patient has atopic dermatitis. As a result, the top layer of Eczematch is a toughened hydrogel that contains a higher concentration of kappa-carrageenan. Underneath the tough outer layer, we have another layer of hydrogel, which consists of the kappa-carrageenan and the PCL nanoparticles that we use bonded to hydrocortisone medication. The hydrocortisone is then administered once the kappa-carrageenan contacts the skin, because kappa-carrageenan allows drug delivery to start at 37 degrees Celsius, body temperature. As a result, the moisture of the skin is maintained while eczema is treated effectively for up to 30 hours using the PCL nanoparticles for slower drug release.
Once the patch is removed, the leftover nanoparticle residue, if any, can be effectively removed with a quick shower. The addition of water will reverse the esterification of PCL nanoparticles and dissolve the resulting carboxylic acid and alcohol. Now let's dive deeper into Eczematch. Why choose kappa-carrageenan? Well, for starters, all carrageenan molecules are linear polysaccharides, meaning they are biopolymers that will degrade faster in any landfill when compared to a synthetic product. Next, kappa-carrageenan is the ideal choice of carrageenan for a hydrogel patch. Lambda-carrageenan lacks gelling properties even in the presence of a cation and can only be used as a thickening agent, while iota-carrageenan only forms an extremely loose, soft, elastic gel. Kappa-carrageenan can form a firmer, elastic gel, which is more suitable for our purpose. In order to form a gel, the kappa-carrageenan molecules use potassium ions to form a double helix structure, which results in a tightly woven durable compound.
We are using polyepsilon caprolactone for our biological polymer that is effective with a drug delivery technology because it is non-toxic, biocompatible, non-immunogenic, and biodegradable. But why does Eczematch use PCL nanoparticles over other biopolymers with similar characteristics? First, they are able to degrade by the hydrolysis of their ester linkages. So as a result, PCL nanoparticles have slow degradability and high stability compared to other naturally occurring nanoparticles. So PCL nanoparticles work to deliver hydrocortisone acetate, a common medication used to treat eczema. Drug delivery starts by engulfing the PCL nanoparticles into a solution of lipid ligands to form a micelle around the hydrocortisone. The hydrophobic tails and hydrophilic heads form a layer around the nanoparticle, in this manner shown in the animation. So the lipid nanoparticle can safely administer medication in long periods of time. As seen in the figure above, the nanoparticles successfully release the hydrocortisone acetate over a long duration. So we can see that the nanoparticles are very successful in doing targeted drug administration because they are 3 times slower than the over-the-counter hydrocortisone acetate cream that is currently available for eczema patients, providing longer periods of eczema relief.
The current market for eczema treatments is very well established, with creams and ointments being the most popular options. These products provide an option for varying levels of drug strength depending on the patient's situation. To get an idea of the wide variety of products already commercially available, a chart from the National Eczema Association website has been included. The organization has categorized 27 different cream and ointment treatments into 7 classes, from super potent to lowest potency. Because of their higher potency, corticosteroids can often cause patients to sometimes have side effects such as high blood sugar levels, increased pain on the treated area, changes in skin color, and tachyphylaxis, which is a rapid decrease in response to repeated doses over a short time period. Also, these options allow the surface of the skin to be exposed to the outside environment, which can often result in dryness, irritation, and increased recovery time. After evaluating all these costs and benefits, our team decided to use a patch combined with hydrocortisone to help avoid these risks. Initially, when our product enters the market, it will only be marketed with the goal of treating eczema patients in the United States. Our target group is the 31.6 million people in the United States with some form of eczema. This group is expected to grow alongside the population. To fulfill demand for our product, we expect to directly sell the biopolymer patches to pharmacies and health clinics. As was mentioned before, our product uses an aqueous solution containing polycaprolactone nanoparticles to slowly release the drug over a 30-hour period. This design can easily be modified by replacing the hydrocortisone molecules in the product with a different topical drug. Therefore, the product would be potentially able to be expanded to treat other skin conditions. Examples include diseases such as hives, acne, or psoriasis. Another room for growth would be expanding our market to younger consumers, in which our hydrogels would be dyed in a wide variety of colors.
Once we identify the promising compound for development, we will have to license the nanoparticles that we'll be using. This will take about 4 months depending on how well negotiations go. Next, we can try to get non-dilutive capital. This can be attained by pitching our product at business competitions, obtaining grants, vouchers, and royalty financing, which will take about a month or 2. Next, we will conduct experiments and intensive research to gather information, which will take about another 6 months. Then we must apply for a utility patent and wait about 10 months till that's finalized so we can start trials. For clinical trials, since this is a class 1 product, so if the patch doesn't work, it won't be life-threatening to the human subject. So the first phase, phase 1, will use about 70 people who have eczema to test our patches. This will take about 6 to 8 months. If our patches work, we can move on to phase 2, which will take up to even 2 years. To protect our plans, we will have to hire a patent lawyer and need to obtain a utility patent because we're creating a whole new product. We also need to license the polyepsilon nanoparticles. We'll reach out to the owner and see what he thinks of our product and if he wants to let us use his patent or not. Using the CARE method of attaining a license, this is where we pitch our idea to him, show how both of us will make money off our product, and give him something in return like a net revenue for a certain amount of years. This will be finalized when he responds to us. In conclusion, Eczematch is specifically designed to treat people with eczema. Our product will be the most effective treatment for eczema that the world has yet to see. That is why with your help, we can help better the lives of people with eczema, which is estimated about 30 million people currently, but we will still expand our product line to other skin diseases in the long run. The dermatology treatment market size was valued at $11.8 billion in 2019 and is anticipated to register anticipated to register a compound annual growth rate of 15.1% from 2020 to 2025. So that's why we need your help so we can reach our goal of $6 million. We expect that in the next 6 years, we will start selling. Each item will cost $2 to make, and we'll sell it for $30. That's a 93% profit margin. If you invest right now, you will get a 5% interest on the loan you give us, plus a royalty fee of $1.50 per unit sold until the loan is repaid. Thank you so much for listening.